A startup's checkout service crashes at 2 a.m. on Black Friday. Traffic tripled. The single container running their payment processor fell over, and nothing brought it back. That outage cost them $40,000 in lost sales. Kubernetes would have restarted that container in seconds. Kubernetes is a system that manages containers automatically. It decides where they run, keeps them running, and scales them up or down based on demand. Think of it like an air traffic control system. You don't tell each plane exactly where to go every second. You set the rules, runway capacity, flight paths, priorities, and the control tower handles the rest. Kubernetes is the control tower for your software. You tell it what you want running, and it figures out how to make that happen and keep it that way. Before container orchestration, teams managed servers manually. Someone would SSH into a machine, start a process, and hope it kept running. When it didn't, a pager went off at 3 a.m. and a human fixed it. That doesn't scale. The moment you're running dozens of services across multiple servers, which is most production software today, you need something coordinating it all. Without Kubernetes, teams write fragile custom scripts to restart crashed services, manually balance traffic across machines, and hand-roll deployment processes that break in surprising ways. The scenario that bites teams hardest. A service silently crashes, traffic keeps routing to the dead instance, and users see errors for 10 minutes before anyone notices. Kubernetes catches that automatically, reroutes traffic, and restarts the container before most teams even open their laptops. Okay, so here's where it gets interesting. Kubernetes runs on a cluster, a group of machines called nodes. Every cluster has a control plane and a set of worker nodes. The control plane is the brain. Worker nodes are where your actual application containers run. Inside the control plane, the most important component is the API server. Everything talks to the API server, your terminal, internal components, monitoring tools, all of it. You submit a desired state to it, not instructions like run this container on that machine. A declaration, I want 3 copies of this service running at all times. That desired state gets stored in etcd, a fast distributed key value store that acts as Kubernetes memory. Then the scheduler kicks in. It looks at your request, checks which worker nodes have available CPU and memory, and assigns your workloads accordingly. It's making real decisions. If one node is already stressed, it picks a different one. On the worker nodes, an agent called the kubelet watches for assignments and makes sure the right containers are actually running. If a container crashes, the kubelet reports that. The controller manager, another control plane component, detects the gap between desired state and actual state and tells the scheduler to fix it. The thing Kubernetes actually schedules isn't individual containers. It's pods. A pod is the smallest deployable unit, usually one container, sometimes a few tightly coupled ones sharing network and storage. Every pod gets its own IP address inside the cluster, and if this is the kind of thing you want to understand, how production systems actually work under the hood, Stack Future covers one concept like this every day. Services sit in front of pods and handle routing. Because pods are temporary, they get created and destroyed constantly. A service gives you a stable endpoint that always points to the healthy pods behind it. Say you deploy a web API using a Kubernetes deployment. Your YAML configuration says replicas. 3. You want 3 pods running that API at all times. You apply it with kubectl apply fdeployment .yaml Kubernetes schedules 3 pods across available nodes. A few hours later, one node runs out of memory. The pod on that node gets killed. Within seconds, the controller manager notices. Desired state is 3 replicas, actual state is 2. It schedules a replacement pod. The kubelet on a healthy node pulls the container image and starts it. Your service never routed traffic to the dead pod. Liveness probes had already marked it unhealthy and pulled it from rotation. From the outside, your users noticed nothing. No alert fired, no one got paged, the system repaired itself because you declared what you wanted and Kubernetes enforced it continuously. That's the entire model. Declare intent. Let Kubernetes reconcile reality. Kubernetes isn't magic, it's a reconciliation loop. You describe the state you want, and it constantly works to match reality to that description. That's the mental model that makes everything else in Kubernetes click. Next up, what is natural language processing and why should you care? A concept quietly powering everything from your email's spam filter to the AI writing tools your team is probably already using. If this actually helped something click, a like goes a long way.